In our Introduction to Alkanes podcast, we're going to talk about what an alkane is, how to recognize it, and we're going to start to talk about the IUPAC system of naming organic compounds. So we'll go into the prefixes. This podcast is going to have a set of prefixes that you're going to have to memorize, so make sure you take really good notes on that. So let's start by talking about what an alkane is. An alkane is a family of organic compounds, and they're only made up of carbons and hydrogens, so we call them hydrocarbons. Very creative and original. The defining feature of alkanes is that they have only single bonds between their carbon atoms. Another term for this is saturated. So if we say that we have a saturated hydrocarbon, what we're saying is that we have all single bonds, and every single carbon has its maximum number of hydrogens possible. So something to always keep in the back of your mind is that carbon has 4 valence electrons. So for alkanes, you're going to have to fill your octet. So your carbon will be single bonded to another carbon, and everywhere else you don't have a carbon-carbon bond, you're going to fill those with hydrogens. So I know we were just looking at this carbon, but let's make this correct and fill this. And the goal here is to make sure that each of your carbons has its full octet through shared valence electrons. So here we have 2, 4, 6, 8. That carbon's happy. And for our other carbon, he gets to claim these 2, 4, 6, 8. So again, the defining characteristic is that you have only carbons and hydrogens, and you have only single bonds. Our formula, generic formula for this is only carbons and hydrogens, and the subscript will be a number of carbons. So in this particular example, let's fill in some numbers. We have 2 carbons, so we would say C2, and to determine the number of hydrogens, we would say 2 times the number of carbons, so 2 times 2 is 4, plus 2 is 6. Now, I do not recommend memorizing that formula. There's no point to that. That's just a quick way to know how many hydrogens you're going to add, perhaps if you're balancing an equation or something like that, but it's not really important for you to memorize. Alkanes with this particular formula are what we call acyclic. So they do not have a ring. They're not connected to themselves. If they were, they'd have one less hydrogen, and that is future us's problem. We are not going to go into that today. You're also going to hear the word nomenclature a lot in organic chemistry, and nomenclature is just a fancy word for naming. All right, so we're going to be doing a lot of memorization in organic chemistry. The first thing that you need to memorize is probably one of the most important things because you're going to be using it all the time this semester. You need to have this list memorized, and you need to be able to work with it almost instantaneously, so get to work on this. Alkanes, alkenes, alkynes, every single functional group is going to use prefixes. So prefixes are going to denote, they're going to be at the beginning of the name that you give to your organic compound, and they're going to denote how many carbons are present in the longest chain, also known as the parent chain. So for example, if it is a 1 carbon structure organic compound, we use the prefix meth. How we finish the word depends on the family, and we'll talk about that on the next slide. If there are 2 carbons, we use the prefix eth. 3 is prop. 4 is but, not but. 5 is pent. 6 is hex. 7 is hept. 8 oct. 9 non. And 10 dec. So there's a couple ways that I like to memorize these. You're going to come up with your own way to memorize those. Some of these are pretty obvious. Like for example, pent for 5, I like to think of the pentagon. It's a 5-sided building or a 5-sided shape. Meth, I think of people who use methamphetamine and how they only have 1 tooth. It's not great, but it might work for you. Hex and hept oftentimes get confused between one another. The way I keep these guys straight is that hex has an X in it, and the word 6 also has an X in it, so the other one is hept. Anyway, write yourself a nice big list that you need to memorize these prefixes, or you will not pass your first quiz. All right, so let's talk a little bit more about our alkanes. So we talked on the previous slide about the prefix or the beginning of the word always meaning that your alkane or your organic compound has a certain number of carbons. Well, say we have a 1 carbon. Let's see here, let's get a pretty color. We have a 1 carbon structure, and it has only single bonds, obviously, because it's only a single carbon. We would consider that to be an alkane. It's only carbons and hydrogens. So therefore, we would end the word with ane. So we would call that compound methane, meaning we have 1 carbon, all single bonds. So what you're going to find is that organic chemistry is very systematic, and it always follows these rules, which is why you have to memorize those prefixes right away. We will also be talking about IUPAC naming systems a lot this semester. IUPAC stands for the International Union of Pure and Applied Chemistry. This is our official naming system. It's very systematic, and hopefully by the end of the semester you will fall in love with it. It used to be that we would name compounds or structures that we find or isolate. We'd name them based off of the plant that we isolated it from, or we'd give some other name. Some people used to name them after lovers. Very strange. So we've done away with that. We use a systematic way, and really this tells you a lot about the structure. 1 carbon, all single bonds. So a lot of times what you've been exposed to, or what you're going to see as a nursing student or as a nurse, is you're going to be exposed to not the systematic name, not the IUPAC name that it's given. You may be more familiar with a drug by its generic or its trade name. So a systematic name is going to be the IUPAC name for it. It's not going to tell a non-chemist very much about that compound. The generic name is going to be more of a common name. It's official. It's been internationally approved name to call that particular substance. The trade name, though, is the catchy one that the pharmaceutical companies come up with that kind of sticks in your mind. It's easy to say. For example, if I had a headache, I'm sure as heck not going to go and ask for 2,4-2-methylpropyl-phenylpropanoic acid. That's going to give me a worse headache trying to find that. I might instead ask for the generic version of that name. I might ask for ibuprofen, or I may call it by its trade name, Advil. When we name alkanes, we're going to try to find the longest continuous carbon chain. Now, this is a lot to take in, but we will do this for every single family, every single functional group that we study. So it's important that you're looking for the longest continuous carbon chain. I like to think of a bracelet, like a charm bracelet, like a Pandora bracelet, or the Alex and Ani bracelets are popular. I am not cool enough to have one of those, so I have made for you a paperclip chain. Okay, so when you think of that bracelet or that chain, you have a longest chain. That's represented by these purple chains. You want to find the longest chain, and that becomes the parent chain. That's what you count the number of carbons. 1, 2, 3, 4, 5, 6 carbons. Okay, so this would have the prefix hex, and it's a paperclip example. It's not great, so we would call it hexane because we're talking about alkanes. Anything that you don't count as part of the longest chain, so this yellow group and this green group, are going to be considered branches. You cannot have a branch be also included in the longest chain. Those are 2 separate things. Once we actually start practicing this, hopefully this is going to make a little more sense. Remember, though, that longest chain of carbons is also called the parent chain. So you're going to hear me use those interchangeably.